This is another section of our intensive multivariable course. In this class, we are going to consider arc length with vector functions. We are going to also do reparameterization. Yes, it's a big word. So we are still under the umbrella of vector functions. So under vector functions, in this particular class, we are going to consider the arc length as well as the reparameterization. And I have problems here to solve so that you know the relevance of these concepts. If this is your first time visiting the channel, don't forget to like, subscribe also, then you share to your friends as well if it's helpful. Arc length. Multivariable is just an application of the calculus 2, which is a single variable, but just there will be some kind of extension. You know from calculus 2 that if you want to find the length of an arc, that is, if you have a curve and you want to find the length of a particular arc, an arc is not a straight line where you simply find 2 points on a straight line. Then you take the square root of what? The x2 minus x1 all squared plus the y2 minus y1 all squared. No, this is a curve. So in calculus 2, we saw that the length of an arc in calculus 2 was the square root of 1 squared plus the squared y, over the square root of 1 squared plus the y over the x all squared, but the formula L was equal to integral of the s, where the s is this expression. In multivariable, we are going to apply a different principle here. As we are in the umbrella of vector functions, we are going to use vector functions in everything we do. So the formula in multivariable here is L is equal to the integral from a to b of the length of my derivative of the vector function r of t dt. You know the derivative of r of t is what we call the tangent vector, yes. So if I find the length of the tangent vector and I integrate it from a to b, I get what we call the arc length, which is a function s of what? T. So I have a problem here which we use to solve, and we get the understanding of the arc length. It said determine the length of the curve r of t is equal to angle bracket 2t 3 sine t 2t then 3 cos 2t. R of t is a vector function and the components are functions. If it's new to you, go back to our previous classes where we started from vector function, their notation, domain, integrals, and derivatives. So in this video, we move straight to finding my r prime. From the formula, I have to find my r prime of t. And that is giving me the function, the vector function, here will be 2. This place will give me 6 cos 2t. Then this place will give me negative 6 sine 2t. I close it. Once I get this, we've been asked to find the length of this. So the length of this is simply the square root of the square of each component of my vector function. So 2 squared plus open bracket 6 cos 2t all squared plus open bracket negative 6 sine 2t all squared. And what is this giving me? I'm going to get 4 plus 36 cos squared 2t plus another 36 sine squared 2t. From my trig identity, I know that if I factorize 36 out, I'll be getting cos squared, I'll be getting plus sine squared, that will give me 1. So I'll simply get square root of 4 plus 36, and that will give me square root of 40, which is simply 2 root 10. 2 root 10. So once I have 2 root 10, I'm good to go. I come back to my function s of t, or the length of arc, which is equal to the integral. I was given an interval from 0 to 2 pi. From 0 to 2 pi. And this is a question, from 0 to 2 pi. So from this interval, 0 to 2 pi of 2 root 10 dt. If I integrate this, I'm going to get 2 root 10, open brackets, t. Since it is a definite integral, I bring my slash 0, 2 pi. What am I getting? I'm going to get, here I'm going to put 2 pi here minus putting 0 there. So 2 root 10 multiplying what? 2 pi minus 2 root 10 multiplying 0. When I get this, this side will go away, then this will give me 4 pi root 10 s of t, and this is simply my length of the arc. Let's go to reparameterization. Reparameterization is just a nice concept which helps us to find the point on a curve after passing a particular distance. So all that you're going to do is we are going to find or reparameterize our function from r of t to a function of a distance, so that we can make a substitution of a distance to get a particular point at where we have reached to get that particular distance. Let's solve the question so that you understand it properly. So in this section, my reparameterization is simply in this sense. Once I have my, let's see my length of the arc. So my length of the arc, I got something here. So I was getting the square root, 2 square root of 10 as my s of t. 2 square root of 10 t. So this is the length function. So if I want to reparameterize this, what I do is I simply find s of t. I take integral of this from 0 to t, 2 root 10, but here I'm not going to use 10, but I'll use u. I'm going to use what? U. So see how it will be done. So when you get this, you are going to get s of t to be equal to, when I integrate with respect to, so I have u here. So I'm going to integrate with respect to what? The u. So I'm going to simply get 2 root 10, then I have what? U. So let me get the u. So 2 root 10 u here. Therefore, applying my 0 to t, I'll get s of t to be equal to 2 root 10 t minus 0, so t comes. Then I make t the subject, which gives me s of t to be equal to, so t will be equal to s of t all over 2 root 10, meaning I've been able to make my t the subject. So once I get this, I simply go and put it back to my main function as I have here. So I have t to be equal to s over 2 root 10. So wherever I see t, I put that there. So now my function, which was r of t, is now going to be r of t of s, meaning we are going to get a function in x. So this is going to give me angle bracket 2 open brackets my s of t over 2 root 10, comma, I'll have 3 sine 2 open brackets s of t over 2 root 10. Then I close my brackets. Finally, 3 cos 2t, so 3 cos 2 open brackets s of t over 2 root 10. I close it. So once I get this, I simply solve for what I have here, these two cancel this, I'll get s over root 10, comma, 3 sine, that one's what cancel, so 3 sine s on root 10, then here I'm going to get 3 cos s on root 10. So now I have reparameterized my main function to the what? S form. So here, when I'm given a question that I should find a point at which my curve has reached after moving a particular distance, I'll simply put the distance here and I'll get that particular point. Let's see how we do that. So I have a particular question here. It says, where on the curve, this curve, after traveling a distance of this, where on the curve is this? So after you have traveled a distance of pi root 10 on 3, where will you be on the curve? Let me try and solve this on this page so that you understand it well. So I have my reparameterized function here, my r of t of s to be equal to angle s over root 10, comma 3 sine s over root 10, comma 3 cos s over root 10. Then after, wherever I see s, I'll put what the question gave me. The question gave me pi root 10 on 3, pi root 10 on 3. So here I'll get pi root 10 on 3 times root 10, comma 3 sine root 10, that is pi root 10 over what? Root 10. Then this side too, I'll get 3 cos, my s is pi root 10 over 3 root 10. So here 2 over times 3 will come here. So when I further simplify this, I'm going to get this root 10 cancelling out this. So I'll get pi over 3, comma, this will also cancel this. 3 sine pi on 3, comma, this will cancel this. 3 cos pi on 3. So this is a nice point I have got. This is a nice point I've got. So this is a point. This is a particular point on the curve at which I will reach after traveling that distance pi root 10 on 3. This is the end of this video. See you in the next class where you consider curvature and the rest. Thank you for joining the class.